Hey, Miss Marion here. We are going to start Unit 6, Lesson 1, and we're also doing Lesson 3 today. If you do not have your workbook, you can go to the Canvas lesson page where you found this video and download the workbook PDFs and also the practice problem PDFs. So make sure that you get out your workbook for Unit 6 and turn to page 109, and we're going to read the I can statement. I can organize data to see patterns more clearly. So you're going to write a sentence and how you feel about that. Give yourself a number. So 1, I don't remember. 2, I kind of remember it. 3, I do remember it. And 4, I can teach it to my friend. We're also going to go ahead and read Lesson 3. I can describe the meaning of a point in a scatter plot in context. And so we're doing Lesson 1 and we're also doing Lesson 3 for today as far as our lesson. So go ahead and write your sentence about how you feel about the I can statement. Give yourself a number. So 1, I don't remember. 2, I kind of remember it. 3, I did get it. And 4, I can teach it to my friend. All right, let's go ahead and turn to page 7. On page 7, it says, here's a table of data. Each row shows 2 measurements of a triangle. You're going to write down what you notice and then also what you wonder. All right, so let's kind of think about some stuff that we noticed. I noticed that the numbers are not whole numbers. I noticed that we're talking about the short side of a triangle. We're also talking about the perimeter. I wonder, why is it set up this way? Why are the numbers just kind of random? Weird. I wonder where the numbers came from. Okay, so anything of that sort, make sure you have something as sentence. I noticed that, blank, fill in the blank, and then I wonder that, fill in the blank also. So this should be written down on page 7. So the information that was we just really saw on our table is actually information gathered from 4th grade students. They were practicing drawing isosceles right triangles and measuring their perimeters. So remember, how do we measure a perimeter? The perimeter is all the way around a triangle, so all 3 sides added together. And do you think there should be a relationship between the length of the 2 short sides and the entire perimeter? So just kind of think about that. Okay. So just kind of remember, with an isosceles triangle, actually the 2 sides are actually the same with an isosceles. That's just a triangle definition. We did talk about it at the beginning of the school year. And then again, the perimeter is adding all the sides together. So let's go ahead and turn to page 8 and 9. On this page, what we're going to do is we do see this same table. And it says, how can you organize the measurements from the first table so that any patterns are easy to see? And then we're also going to go ahead and write those down. So think about for a second, what is a way that we can go ahead and organize this information? Okay, and so we can actually probably put them in order. And so let's go ahead and take the time for a second. Let's take all these numbers. Let's put them in order in the table that is open. Okay, and then I kind of see a pattern of what's going on. So go ahead and pause. Do that, pause, and then come back to me. All right, here is the table. Put them in order. So anything that we notice, so we do have them in order, kind of going up here. Notice how we have different measurements. I do notice that they're kind of random, actually. They're not linear like we've been doing. And we're actually going to be talking about that today as far as kind of the reason why and what goes along with that. So on number 2, also on page 9, it says, for each of the following lengths, estimate the perimeter of an isosceles right triangle whose short side has the same lengths. So the length of the short side is 0.75. And B, the length of the short side is 5 centimeters, and the length of the short side is 10 centimeters. Go ahead and answer those questions, and then come back to me and see if you got them correct. All right, so the length of the short side is 0.75. So here's 0.5, here is 1. 0.75 is going to be kind of in between here. So it goes from 2 and then to 3.5. So this is an estimation, so kind of remember that. So I'm thinking it's going to be about 2.25, and then it's centimeters we're talking about. All right, B, it says the length of the short side is 5. So I have 4 way down here. This is 6, so it's 14 and then 22. So kind of like It's more closer to the 4 than the 6.5. So I'm thinking probably it's going to be about 17 centimeters. And then the shortest side is 10 centimeters. So we kind of have to kind of think about what's going on. How does it change? How is it going up? So each time the length of the short side, so that's the short sides here, goes up by 1. The perimeter, if you kind of look at it, it goes up by 3. Okay, and so when the short side length is going to be 10 centimeters, well, if we kind of follow the same pattern, it's probably going to be around, I don't know, about 30 centimeters. All right, so we're kind of looking again at just different patterns, different things. On page 9, this is Are You Ready for More? What information can you see in these maps that would be more difficult to see in a bar graph, showing the number of electoral votes for the 2 main candidates? And why are these representations appropriate for the data that is shown? So kind of like think about it for a second. If I had this in a bar graph, would that be easier to see or would that be harder to see? And so if we think about it, the map showed the many votes that are going on, right? And in the Northwest, they tend to vote for Democratic nominees, while in the Southeast, they vote for Republican. So if we're looking at the different pieces, so Northwest is the Northeast, okay, up here, more Democratic, okay. Down here is more Republican, right? And so we have the different things. This is 2012. This is 2016. So we can kind of see a pattern. Notice how it kind of changed a little bit. And so these are things that you're not going to be able to see with just a bar graph. You can kind of see areas. And when they go ahead and do votes, of course, we just barely went through an election, right? They actually look at kind of what's trending, what is changing, and that's where they focus more of where they go and they talk to all the candidates and different things to get them on their side, right? So this, as a picture-wise, would actually be better than just a bar graph. So what patterns do you see in this data when it's graphed? So here is a different graph. Notice how the points are not in the same like line kind of thing. And we call this what is called a scatter plot. So math is not creative, scattered. All the points are scattered and they've been plotted on a graph. Okay. So scatter plots are when 2 numerical variables are graphed by using one variable as the x-coordinate and one as the y-coordinate. Data pairs are also represented as plotted points. Okay, so we've been plotting points on graphs. This is considered a scatter plot because the information is scattered on the plot. Okay, so on page 10, we're going to talk a little bit more about scatter plots. On page 10, we have 4 different graphs. We have the points that are on there. And what I'm going to do is, in a second, I'm going to show you 4 different tables. And what you're going to do is you're going to take the graph. So you're going to have to be looking at your workbook to be able to go ahead and do this. You are going to match the table with the graph. And so you're going to make that decision. You're going to go ahead and give the graph a title. You're also going to go ahead and label the X and Y axis of that graph also. And so again, in a second, I'm going to give you those tables to go ahead and look at. So again, here are the tables that we're going to go ahead and look at. And then you're going to match them to the graphs that are on page 9. So again, each graph needs a title. Each graph needs an x-axis and a y-axis labeled. So pause right now. You're going to have to pause and go ahead and write that information down and then come back to me. All right, here are your answers. So notice how the first graph is the used car price versus mileage. We have price in dollars as my y-axis. I have mileage as my x-axis because the price depends on the mileage of the car. And notice how it goes down also. This is normally about cars. August daily high versus energy consumed. So energy consumption is on the y-axis because energy consumption will depend on the degrees that they are. And it's also going up the hill. Next one is diamond prices versus size of carrots. So the price depends on the weight of the carrot. And notice how the higher that we go in the weight, the higher that goes on the price. And then this is new car versus fuel efficiency. So the fuel efficiency is going to depend on the weight of the car. And so notice how it actually is going to go down on as far as the fuel efficiency. That the heavier the car becomes, the less fuel efficient it's going to go ahead and be. So in this first lesson, we talked about scatter plots. And sometimes sorting information in a table is great, but then also sometimes putting that information onto a graph is a little bit better to see kind of a trend. And we're looking to see what's going on with that piece of information. So on page 11, go ahead, there is a glossary term area. So in that area where it says scatter plot, go ahead and write a definition for scatter plot. Mathematically, the definition is a scatter plot shows a data point for the relationship between two variables on a pair of coordinate axes, one for each variable. That's my mathematical terminology for scatter plot. You can use that one or you can use your own, but make sure you understand what that definition actually means and write down that definition on page 11. So let's go ahead and go into lesson 3. So we're on page 23. This is a giant panda, lives in a zoo. What do the points on the graph tell you about the panda? So go ahead and write that on page 23. What does 36,82 actually mean? So pause, answer that question, and then come back to me. So what does this actually say? Well, the easiest way to do it is to go ahead and label that point, right? We have 36 and then comma and then 82. So the 36 is the x-axis. Well, that's the age in months. So at 36 months. And then what is the y-axis labeled? That's weight. So at 36 months, the panda will weigh 82 kilograms. So put it in a sentence: at 36 months, the panda will weigh 82 kilograms. So go ahead and make sure that you have this sentence written down on page 23. All right, on page 25, we again are going to be working with a scatter plot. This is the table as far as the information, and it was put onto a scatter plot, and it shows the weight and fuel efficiencies of 18 different cars. So knowing this information, the table, and then also the graph, let's go ahead and answer the first 3 questions. 1, which point in the scatter plot represents car L's measurement? What is the fuel efficiency of the car with the greatest weight? And what is the weight of the car with the greatest fuel efficiency? So go ahead and answer those questions. So pause and come back to me. All right, the easiest way to go ahead and answer number 1 is actually from the table. If you look at L, that we have the weight. So what is the weight that it is on as far as the L? Well, that is 1,663, 19. So that's that point. Number 2, what is the fuel efficiency of the car with the greatest weight? So if you look at the weight part, the greatest weight is car G, which is 2,384. And then what is the fuel efficiency? Well, that is 16 miles per gallon. And then the last one, what is the weight of the car with the greatest fuel efficiency? So if we go ahead and look at it as far as the greatest fuel efficiency, so the greatest weight, so the weight would be 30. What is the fuel efficiency? So that's 1,234 kilograms. Moving on to the next questions. So we're going to do 4, 5, and 6. Car S weighs 1,912 kilograms to get 16 miles per gallon. On the scatter plot, plot a point that represents car S's measurement. Number 5, car N and O, shown in the graph scatter plot, are made by the same company. Compare their weights and fuel efficiency. Does anything surprise you about these cars? And number 6, At different companies make cars F and G, compare the weights and fuel efficiency. Does anything surprise you about these cars also? So you're going to have to go ahead and pause this, answer those questions, and then come back to me and we'll talk about it. All right, so we're looking for car S, and it weighs 1,912 kilograms, 16 miles per gallon. So let's go ahead and let's plot that point. So we have 1,000. So if we look at it, 1,912, it's probably going to be somewhere around here. And then we also need the 16. So let's kind of put both of those together. What point do we get? That's this one. So this is actually number 4. All right, moving on. Car N and O. What do we see about those? Car N has a lower weight and a higher fuel efficiency than car O. And anything that we notice, nothing is surprising about the cars because they fit in with the trend. They're not like an outlier, meaning they're not out by themselves being there by themselves doing nothing. Okay, so they kind of follow the same trend. They're actually okay. Looking at number 6, cars F and G. Their weights are quite different, but they still have the same fuel efficiency. And it's surprising that the cars with such different weights can still have the same fuel efficiency. So maybe that the different car companies, they make it so that it works better as far as having the fuel efficiency, even though one of the cars is actually weighs more. All right, let's go ahead and enter to page 27 to 28. As I kind of notice, I'm actually missing numbers 1, 2, and 3. Sorry about that. So let's go ahead and go through this. This is a clothing company. We have the data in the table, and then we also have a scatter plot. So we're going to actually work through numbers 1. So number 1, it says, what does the point 15, 680 represent? Go ahead and answer that, and then come back to me. If we were looking at 15, 680, the 15 is the temperature in degrees, and then the 680 is the coat sales in dollars. Number 2, for the month with the lowest average temperature, estimate the total amount made from coat sales. So let's go ahead and answer that also. Again, this is number 2. Sorry, it's not on my page here. So again, we're looking at for the month with the lowest average temperature. So lowest average temperature. So the lowest average temperature, so the temperature is at -5 degrees. That's $1,550. Number 3, for the month with the smallest coat sales, estimate the average monthly temperature. So smallest coat sales, well, if we look at it, okay, we have 410. That's about the smallest. It will be about 23 degrees Celsius. Now let's go ahead and go into number 4. If there were a point 0, A, what would it represent? Use the scatter plot to estimate the value for A. So think about as far as what does this actually mean. If the temperature was about 0, okay, because that's the Y. So if the temperature is 0, what would be the amount of money that they would do? So let's go to 0, kind of come up here. So if we follow the trend or to follow the data, I'm thinking it's going to be about $1,220. Okay, we're going to do the same thing with B. What would point B, 0 represent? So remember that if we have it as $0, what would the B represent? So the dollars are going to be 0. That's if we're going to kind of be down here. If we're following the trend, keep on going, keep on going. Oh, it's probably going to go ahead and be about, I don't know, 30 degrees Celsius. As far as the degree. And that's if we're following the trend or following the data down the graph. And then number C, would it make sense to use this trend to estimate the value of cells when the average monthly temperature is 60 degrees? Explain your reasoning. So would this work if we had 60 degrees? And honestly, if we follow the graph, we kind of read it from left to right going down. Would this work for 60 degrees? Not really. It doesn't make sense. Um, because 60 degrees is hotter than it has been recorded on Earth. Okay, so that's 60 degrees Celsius. If you do a translation of Celsius to Fahrenheit, that's about 140 degrees Fahrenheit. Would this actually work? Not really. Okay, so again, you have to know the different conversions back and forth, but no, this would not work because technically it's 140 degrees Fahrenheit. So again, today we're looking at scatter plots. Scatter plots show two different measurements. They are information that's not on a straight line. Their information is plotted onto a graph. And usually there's a trend that you can figure out. Either it's going up the hill or it's going down the hill kind of thing. But a scatter plot will never be a straight line or a curvy line. It will just kind of be everywhere on that graph. So let's go ahead and turn it back to page 109. This is lesson 1, I can statement. I can organize data to see patterns more clearly. Give yourself a sentence and also how you feel about it. 1, I don't remember. 2, 1, I'm still confused. 2, I kind of got it. 3, I did get it. And 4, I can teach to my friend. And then we're also going to do lesson 2. We're going to do lesson 3. Lesson 3 is on page 110. I can describe the meaning of a point in a scatter plot in context. This is lesson 3. Again, write yourself a sentence about how you feel about the I can statement. Give yourself a number. So 1, I'm still confused. 2, I kind of got it. 3, I did get it. And then 4, I can teach it to my friend. So remember, we are doing 2 lessons. That means we have 2 practice problems. We're doing practice problem 1 and we're doing practice problem 3. So, and those can be found in Canvas underneath today's module. This week's module is Friday, and so we're doing both assignments. Hopefully you understand it. Have a good day. Thanks.